Clay, you're with me in Dallas. John, where are you dialing in from?
I'm dialing in from Miami. I've told you before, I'm calling it the Bay Area, man. I'm just gonna try to like own that phrase now.
John's making
Beautiful sunny Miami.
Miami the new Bay Area.
That's
Audience,
right.
you
Right.
have a chat tool in Zoom. If you're joining us, if you registered, you're joining us via Zoom, and you can participate in the Q&A. You have a chat tool. Let us know where you're dialing in from. And Clay, you can read it back to us. A couple of notes for the audience. We have folks joining via the live stream, and we have folks join that have signed up and registered to join us via Zoom, and they can do that. Anyhow, welcome to DPE Lowdown, DevProdEng Lowdown. We call DevProd Engineering DPE. And we've been doing these webcasts for years and talking to folks like John, who are experts in the industry, to get the lowdown on how John and his team have been doing some really cool stuff in develop productivity engineering for their customers, for the industry, and whatnot. So it's a deeper dive into developer productivity engineering case studies, use cases that you can hopefully learn from and try out and learn about new tools and whatnot. I'm Ruse from Gradle. We'll also have Clay on my team, on the Gradle team. He's helping us out with the Q&A, and he's on the Develocity, formerly Gradle Enterprise Engineering team. So he's helped John and team get some stuff set up that he's going to talk about as well here.
Nice.
John, yeah, my old pal. When did we first meet? When did you join
Gosh,
Netflix?
probably 2014, right? So it's 10 years, about 10 years
Wow.
now,
Yeah,
right?
about 10 years. Yeah, yeah.
Yeah.
And so you're the CEO of Moderne, and co-founder of Moderne, and it's the company behind OpenRewrite. And
Yeah.
before we jump into that, obviously I know what you're doing, but the one thing in the industry that you got a lot of great press out of it, and it could kind of help set, what is OpenRewrite, what is Moderne, was that, Andy Jass, the CEO of Amazon, Adam, and he at Amazon reInvent, he was talking about Amazon Q code, and he was mentioning, this is his quote: 1,000 applications upgraded in 2 days. And that was how a part of that uses OpenRewrite and whatnot. Tell us a bit about that exciting news. It's a big thing. reInvent is huge. And for you to be mentioned there, kind of give us the story from there and what OpenRewrite is and what Moderne does.
Yeah, absolutely. I mean, pull back the curtain a little bit. I mean, we didn't even know Amazon was working really with OpenRewrite until the Wednesday before Thanksgiving, right? The week before AWS reInvent. And I get a text from Miles, our like AWS rep, and he's like, "Hey man, I really need you to be on this meeting later today." And I thought, well, that's a little weird, right? Like I'm not, I'll be on meetings, but like, it's weird that I was like getting a text from him. I really need you to be here. And we join, and there's like a group of folks from Amazon ready to kind of say, hey, just so you know, like, we kind of built on top of OpenRewrite. We did some things internally. We're going to announce it at reInvent next week. Hopefully you're okay with that. You want to put a quote in our blog post. And I honestly think there was a bit of apprehension on their part. I think they're used to this, like, kind of building on top of open source tools and that not being necessarily received really well. But in our case, I thought, it's perfect. It's great. It's exactly what we want, to take that really like Apache license recipe out there, like Java 8 to 17 in their case, and just, go make hay with it, right? Go update your apps.
Well, amazing. And tell us a bit about your company, Moderne, because we're going to refer to Moderne. We're going to refer
Absolutely.
to OpenRewrite. We are at Gradle. We have Gradle Build Tool, the open source project. We have Gradle
Right.
Enterprise. We changed it to Develocity. What's that
Yeah.
relationship, and how does that work?
We're going to talk about all of these things. Yeah. So, I mean, OpenRewrite is the kind of core refactoring engine you can say. That's really built to do big mass code changes, whether that be Java 8 to 17, whether that be fixing vulnerabilities, whether that be fixing old SaaS type issues, a lot of different use cases. But Moderne is doing that at massive scale. So taking those open rewrite recipes and applying them and developing them on hundreds or thousands of repositories at a time. So it's a kind of classic, the commoditize your complement. We provide a refactoring engine in open source, and then Moderne is like a distributed data warehouse for code, executing those across a whole code base.
And I love telling great stories. And when you and I chatted before this event, we're going to show some stuff later of exactly how some of this worked. But I love to start out with great stories. So you and team, very similar to our Develocity and what I do, you're going around to these large organizations, these large software organizations, and helping them with developer productivity, modernizing their code base, tech debt, you could even call it, right?
Yeah.
And one story that you and Pat were telling me to kind of start with that was this very large insurance company. And I'm reading Pat's quote here, it was about, Spring Force shell, vulnerability hit, and they had to update all these what they call maintenance stories, and you all were able to tell us how all that became. What was the need? And tell us a bit more about that, because I thought that was very interesting.
Yeah, I think this is a really interesting company in particular, this insurance company. They had their backlog, and their typical agile shop. Everything's in the backlog, story points assigned, but there was one more thing. They had every story in the backlog tagged with either maintenance or, business feature, right? Like business requested feature. I think the word maintenance is actually a really interesting word that they chose, not technical debt, because, the word technical debt used to really have this meaning of something I imposed upon myself. Like I took a shortcut intentionally to get something out the door. I'm going to have to go down and pay down that debt at some point. But what's interesting, with modern software, we're building on a bunch of open source and third party stuff. You have to, right, to ship new experiences quickly, but that stuff shifts on its own, right? You don't have control over that. So just by building this, software production is very industrialized. It requires maintenance on the back end. So they really recognize that maintenance and SMRs or business features. And, if you kind of look back at them quarter to quarter, over the years, there was one product team that delivered a certain amount of business functionality and a tiny amount of maintenance every quarter. And that's just how it went. They were really good about estimating how many story points they could do on each. And somewhere in that Q2 when Log4Shell hit, they did less business delivery and more maintenance that quarter, right? Because they had to go and switch off and go fix all this stuff across all their apps. So it was really mechanical work, but they had to do it. Then at the end of that year, they had started with Moderne. They were starting to fix these maintenance stories with recipes that would just make the change across all their repositories. Well, that was closing maintenance stories a whole lot faster than it used to be. So interestingly, their maintenance work for that quarter went up by 1,000%. And their business functionality delivery went up by 30% because the teams weren't switching off of business value delivery to go do this kind of grunt work, maintenance on the side. The funny thing is when they did that team guy kind of went to the business and reported their performance for the quarter. The business guy actually kind of got mad initially. They're like, why can't I take that big maintenance bar and stack it on top of the business one? And they're like, oh, no, wait, I wasn't doing that stuff by hand, right? I was doing that maintenance with automation instead. So I think that's a really interesting forward-thinking way of viewing maintenance versus business delivery in their case.
And where did Moderne and OpenRewrite play a role in that?
So it's when they needed to update, a dependency across their whole footprint. You can do that commit all at once across a whole business unit rather than having to go to each repo and making that change one by one. You could fix, a I'm trying to get rid of an old API and replace it with another. You write a recipe to do that. Then you just mass effect that change across the org. This is a company, by the way, that, years ago, they had like 70 engineers. They had like 40 repositories. If we wind back 15 years ago. Today, they still have 70 engineers, roughly 3,000 repositories. And that's the pattern we see over and over again. It's just like explosion of code under maintenance. But, the headcount isn't growing. So if you want to accomplish any one, maintenance activity, you're going to have to do it across just so many more repositories.
And that's pretty impressive that, tooling allows you to scale your business without having to increase engineering headcount. And
that's right.
So that's quite impressive. And we're for our audience, right? Maybe some of them aren't familiar with OpenRewrite, not familiar with Moderne. How far does the open source OpenRewrite get you? And when do you need to kind of look at an enterprise solution? And it's always a build versus buy kind of thing in the open source world, right? I either got to build it myself or I got to buy yours or whatever, something. Where does that kind of happen?
Let's think about this like in general as like tech stack liquidity. It's about being able to move, to not be ossified, to not be stuck on one thing. Now that could be a framework migration. That could be Java 8 to 17. I don't want to be stuck on Java 8. I want to move to Java 17. But it also could be, hey, I'm trying to move off of one IAM provider and onto another. I'm trying to move from one monitoring system vendor to another. And to accomplish that, I've got to go through my code. I've got to basically iterate over all my code and make these code changes all throughout the code base to do so. And so I think when you there's like different kinds of recipes. When it's like Java 8 to 17, that recipe is super well battle tested. A lot of people have used that to great effect. And so an Amazon's able to take that one off the shelf, rip over 1,000 repos, done, great. But oftentimes we're going into environments and we're trying to do something unique. I'm trying to kill an internal feature flagging system and go to launch darkly. I'm trying to move from this to that. And so that starts with a discovery exercise. That starts with a recipe that emits data, that does an impact analysis. I understand how things are used. And so having that engine to be able to execute that recipe at scale and iterate on it very quickly leads to a good outcome. At another bank, we were doing that IAM provider to IAM provider migration. And we just started looking at the whole set of code base in the commercial bank. And as we developed that recipe, we would run on the entire commercial bank. And how effective is that recipe? Oh, we need to make this change too. Run it again, run it again, run it again. When that feedback loop is only minutes, you can really kind of quickly get that new custom, transformation done.
That's great. And great segue into the next topic. Like I said, I love telling stories and hearing great stories because I'm out there in the trenches dealing with some of this as well. You and Pat mentioned, and Pat works on John's team. She mentioned, hey, we're helping this large Canadian bank. And I guess they ran Sonar Cube reports. They identified a ton of security vulnerabilities and security related issues. And for them to manually fix those, it could have taken years.
It said 4.9 years of developer time to fix manually. That's what their tool told them. Isn't that crazy?
Yeah. So then you just basically got to put everybody on that because you're a bank and it's security related and good luck delivering any product or don't.
Yeah. And face pay the piper someday when it comes. Like, I think too often that's what happens is that, there's just such a pile of work to do. It just doesn't get done. So, it's cute to say shift left. It's the developer's responsibility to fix all these things. But when you keep shoveling things over onto their plate, like there's only so much they can do. It's kind of a heroic lift. It's too much. So,
tell us what happened at this bank. So tell us the story. So they ran the Sonar Cube reports, they identified some vulnerabilities. How did this come about and what happened next?
I think this is a great way these things happen is like you run an existing scanning tool like that. It reports a ton of work to do. Like, let's just pick the top 5 things, top 5 security things that this is reporting. We don't have to do everything today. Let's just pick the top 5. And we say like, well, if we don't have recipes for these, let's develop another recipe for these 5, right? It's only 5. And for those 5, it said 4.9 years of time to fix. There was, so provided the recipes, they work, they're available to commit. I like making the recipe available for product teams to run at a time that's convenient for them. Like they may be in the middle of a fire drill right now, trying to get a feature out the door. Tomorrow they have more downtime. That product team needs to be able to execute that recipe at scale and do the commit. So in a moment when they're not kind of like under the gun, they can get it done. And there was a developer in the back corner that just like mass committed the results of that recipe, like direct committed it to like hundreds of repos. And nobody knew he was doing that. Actually, like I didn't know he was doing that. And his boss came down and was like, what is going on down here? Like, who is this guy? Right? Because it's like a 1 year out of school. And this kid's like quiet kid in the corner, just like makes a bunch of commits, right? And you can imagine if that's like hooked up to a system internally that's like so-and-so made a commit, so-and-so made a commit. So they're like, who is this guy, right? Like, who's this like developer that's just like fixing this stuff across the whole wing of the company? And, you kind of got like this raised hand, right? I guess it's me, right? So I think that's just beautiful. I think that's how it should be. Yeah.
Yeah,
I love the too that he was young, right? Like I think you get that young, ambitious developer that like wants to make a mark. They're going to make a mark.
And we talk about all the time, right? Folks get used to the pain and they get used to their ways, and it's really hard to get folks to change. I'm sure that developer got a nice promotion.
Right. Certainly on the radar of his boss now.
Hey, that's pretty awesome.
Yeah.
So now we've told the stories. Kind of audience has got an idea of how these things could be used in the wild to handle tech debt. When you take a lot of this tech debt, and some of it is high priority. You mentioned the security related stuff and whatnot. Off folks' hands, it substantially improves developer productivity. You want to show us something about OpenRewrite? And Mike, one question that I had, sorry, going off script a bit. When did you start working on OpenRewrite?
Yeah, a little history
there. Was this something,
an
idea that came out of Netflix? Because, for folks who, I might have forgotten to mention this at the beginning. John and I, Netflix, big Gradle shop, they use Develocity. And my team and John, we were working very closely together for many years.
For a long time.
The Nebula Gradle plugins and whatnot, that
even
collaboration. Hanging out at the Netflix Los Gatos office. When in that, and you came to Gradle for a while and all that. When in this journey did the idea for OpenRewrite come about, and when did you start working on it?
Yeah, there's actually a connection to Gradle there. I was working on build tools at Netflix originally which is a subset of engineering tools in general, which is a central team. So build tools, we were, one of the first things I did was help Rob Spieldiner at the time move the remainder of Netflix's code base from Ant to Gradle, believe it or not. That's in 2014. We were still kind of chewing through that. But yeah, once everything got on Gradle, like there did become, if we wanted to make a change in a Nebula plugin, we were trying to get people to do it. Like, how do you spread that across, tens of thousands of microservices? Like, if you want to make some sort of change. And so we spent a lot of time, I spent a lot of time personally trying to build reports, build dashboards or actionable insights for developers to know what we wanted them to do. Like colorizing Jenkins output, doing all sorts of crazy stuff. And it resulted in basically no action on the part of product engineers. There was freedom and responsibility culture at Netflix, which was kind of special. So as a central team, I couldn't impose a constraint on what they did. I couldn't say if you don't convert to, Gradle X by this date, I'm going to break your build. No, that's anti-cultural. You have to find a way to help them move forward. And so reporting wasn't doing it, which I guess should be no surprise, but I mean, like, I'm stubborn like everyone else. And I think when I would ask people, what could I do? They would always answer super sarcastically. They'd be like, well, do it for me. Otherwise I'm not going to do it. Right. I got something else to do. But there's only like 3 or 4 of us on the build tools team, and there's like 700 of them. So, that's not actionable. So we started thinking about, like, even in just the Gradle build, how would I automate this? So I created a tool called Gradle Lint over, I think, like Christmas 2015. Gradle Lint was really about making AST changes in Gradle Groovy scripts to, like, push things forward a little bit. And then from there, it was like, well, if we can do this in Gradle Groovy, like, what about the main source code? What if we could, like, make changes there too, right? And then so OpenRewrite was born out of that kind of incremental realization that, we needed to find ways of, like, mass refactoring this code base.
Awesome. While you pull up something, you want to show us a quick demo and whatnot. Clay, any interesting questions from the audience? And audience, you have a Q&A tool with your Zoom that you can ask us anything interesting from the audience. Let's take one, and then we can take more questions at the end of the Q&A section.
So we don't have any yet, but I'm watching it closely. So feel free to ask questions. I'll bring up the good ones. We'll discuss them live.
Yeah. If we switch to a screen here, I think I would start with a particular change. This is JUnit 4 to 5, which, I mean, I like this example because it's unit tests, right? It's like it's a unit test. It's not my main production source code that's actually, like, serving customer requests, actually delivering value to the business. It's unit tests. Now, unit tests are important, obviously, but, like, not in the critical path. And yet, I find it interesting that, like, Spring Boot 3, for example, you have to move to JUnit 5 in order to move to Spring Boot 3. You can't stay on JUnit 4. Like, it's end of life, right? It's done. And Spring Boot 2 is end of life now. So when I think about the reasons why people get stuck, why they have, like, thousands of apps still on Spring Boot 2, it can be silly things. It can be things like, well, I haven't, like, hand moved all of my JUnit 4 tests to JUnit 5. And now the next time, like, now Spring Boot 2 is end of life, right? The next time there's, like, a major 0-day security vulnerability discovered in Spring Boot 2, are you going to be able to move to Spring Boot 3? Or are you going to be stuck? And ironically, the thing that could keep you stuck is the fact that your unit tests haven't moved to JUnit 5 yet. So I think, okay, so move to JUnit 5. How hard can that be, right? And our temptation is to think, well, maybe this is stuff I can do with, like, find and replace. Because after all, like, the JUnit author changed or JUnit before or JUnit Jupyter API before each. And so, like, I've got to basically go replace every, like, annotation before with before each. It's just like it's name change. It's like a different package that it went into. But the changes can be super subtle. Like, you can't use this run with annotation anymore in Spring. Like, you used to be able to define an exception on the test annotation, and now you got to use an assert throws and shove the rest of this method body into a Lambda. And, oh, by the way, like, I'm changing the imports here as well. And what if this was a wildcard import? Like, how would I know when I'm removing assert false that, like, that's an import that's getting pulled out of that wildcard? And, like, how many? So OpenRewrite is, like, way, 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 way beyond, like, a find and replace sort of mechanism. It's not like a regex thing. It's like, it's a rule-based system that's making really AST or syntax tree. We call it the lossless semantic tree because it's got other information about it. Changes. It's making changes at the tree level and then printing it back out to text. And as it prints it back out, it's making the changes look idiomatically consistent in the context of each repo the change is being inserted into. So in this case, this project uses wildcard imports only when there's 5 or more types. So you see that there's 4 import statements here. If there's one more that would get changed to a wildcard, this one project uses tabs, so I got to use tabs. And so to make it look like a developer on this project handcrafted this change line by line. And it's a rule-based system. So it's a rule-based system that's guaranteed to make accurate change. No, like, AI stuff here, no fuzziness, right? Like, it's guaranteed to make that accurate change. And I would have to, if I was a developer on this project, trying to move this project to JUnit 5, I would have to do this by hand, just over and over and over again. this kind of stuff just is absolutely soul sucking, right? Like, I mean, who wants to do this? I signed up as a developer to be a creative, like an artist, not like a guy that goes and does this kind of stuff. Like, and this is one repo. That's what amazes me, right? So think about that insurance company, 70 engineers, 3,000 repos. I got to do this 3,000 times? Or the alternative is I just get stuck on Spring Boot 2 forever. That's the reality, I think. So I think that's where, like, so this is the kind of like core idea of OpenRewrite, is to be able to make that change at scale, to make it look idiomatically consistent in the context of a bunch of repos that have different styles, so that a developer can accept the change quickly and then move on.
Amazing. Another, do you have something you want to show for Moderne as well? We have an OpenRewrite question. Maybe let's take that question real quick, and then.
Yeah. So if we kind of, and just we'll go back to the window here that's sharing. If I'm thinking about Moderne, so if I'm looking at Moderne is like, there's 2 editions, but there's a single tenant SaaS that we run isolated for each customer. The edition that we're looking at right now, app.moderne.io, is an instance of Moderne that we run for about, you can see, 35,000 open source projects. Inside of this tenant is 2,000 Jenkins plugins, the entire Spring org, the entire Apache org, the entire Eclipse org, the entire JUnit org. Like, so we're pulling in like the most common stuff that we all depend on, and we also deploy recipes there. So I could take like one of these recipes, like, and we'll go back to this one that this bank did, common static analysis. Common static analysis is a recipe which has a bunch of other recipes attached to it that just do like SonarQube auto remediation. We even tag them with the equivalent SonarQube issue. So like SonarQube says, you shouldn't do this, non-compliant, compliant. We will rewrite this rule as an OpenRewrite recipe that both finds and auto fixes that issue and add it to this pile. So this pile just keeps growing, of various things. And so I've selected 38 repos in my org, my open source org right now. If I dry run this, the idea here, the reason I'm able to do this really fast is because in Moderne, I've pre-parsed all this code in that lossless semantic tree form. So then I can rip over it with recipes really super quickly. If I was doing this with OpenRewrite to run this recipe, I would have to compile each one of these repos from scratch to parse it into an LST. So this would take probably hours to do. Just with OpenRewrite, I'm able to do here in a few seconds. If I'm developing a new recipe, to be able to iterate this fast is super important. If I look at one of these changes, like, I could say like, what's going on here? Why did this change? Well, unnecessary parentheses. Cool. Got it. What is this other thing? Like all these kind of things. And so as a developer, the goal here would be that I could actually select all of these and say commit. And I'm going to commit to 16 repos with my credentials. So it's going to show up as I'm the author, Moderne is a co-author, or I could issue PRs, or I could, that kind of thing. But like, I am doing work very efficiently. I'm fixing these issues across all 16 repos at the same time. That's kind of the goal. Yeah.
And we're talking to some Develocity for Gradle enterprise customers that want to do similar stuff. How can this help our customers?
Yeah, I think one of the great stories with Develocity is like, once Develocity is available to an organization, a new customer of Gradle's, to get the most out of it, they've got to configure that Develocity plugin in their builds. Well, they've got a lot of builds. So that is very much a change, that you need to do. So I could look at, for Develocity here, and there's an add the Develocity Gradle plugin at some particular version to the build, and I could then execute this on hundreds or thousands of repositories. Ta-da! Suddenly they're all using build cache, they're all using test distribution, they're all like immediately realizing the benefits of Develocity as opposed to like waiting for this to be installed one at a time on each repository.
That's awesome. Can we get Clay in here? Clay, could we use this this technology to, for example, enable Develocity for local builds? And
Absolutely. Sorry, finish your question. Yes.
Local builds, the cool custom values, the tagging and whatnot. So we update some stuff. We could roll that out with Moderne.
Exactly right. We have tricks we use to try to make this easier for people, but ultimately the way we want people to connect builds to Develocity is to touch every source repo with this configuration that allows the upload of build scans to Develocity, right? Then you run into issues. You come into a large organization with thousands of source repositories. Develocity could give them the data on where they should focus their efforts to optimize those builds, but we need to connect those builds first to get that data. So you get this chicken and egg problem that's very elegantly solved when you can do something like this.
Well, that's amazing. Let's take, we had an interesting question from the audience, Clay.
Yeah.
You want to share that with John?
Yeah, sure. So someone asked from the perspective of an organization developing optimization software for automotive and space. Code base is 1 million lines long. This person they say it's written in Java using a swing as a front end, wanting to understand the concrete things that OpenRewrite gives them there.
Yeah, so once you've identified a pattern, like whether that be a performance pattern, a security pattern, a modernization pattern, whatever it is that you would like to see applied through your code base, you kind of like, just like as developers, we always encapsulate things we know. You encapsulate that knowledge in a recipe and you can apply it. I remember talking to one principal engineer at one point. He said, I feel like I'm going around telling my kids to pick up their socks all the time, right? Like I've got this idea of what I want my code base to look like, but I train the devs that have come on board to my team, but then I get another crop of devs the next year, or, I'm getting code from a consultant or from an acquisition or, and so it's just constant. And so I want them to think, what if you could automate the picking up of socks to the point where you're going to run it today to pick up all the socks, but then you're probably going to run it in perpetuity to slam the door shut on that issue too. It never comes back. I think that's kind of the potential.
Clay, we got one more that's interesting. Let's take that and then we move on to our last two topics.
Yeah, there's a specific question here. I may generalize it a bit as well. Someone in the Q&A asked if OpenRewrite contains recipes for upgrading query DSL. I think what may also be an interesting thing to talk about is there's a lot of potential here. Where can I go to see what is already available? What can I already just grab and use?
Yeah. Query DSL. I'm trying to think of what that is. Do you have are you?
We have a link. We can save that we can put a pin on that and come back to it.
Yeah. I think in general, anything though that you can really describe step to step, and it may be a multi-step operation. If you can think about the problem algorithmically, you can do it probably. So, I mean, if I think about boundaries, right? Anything you can describe by steps you do, anything that involves a creative exercise, I don't think you want to do with OpenRewrite. So I don't believe there will be a future where I take a 50 million line COBOL application and out comes a Java application that's fully modernized on the other side. I don't think that's realistic. I think you really need to consider that's a creative software building exercise right there. But then where is the line, right? And the line cannot always be immediately apparent. If you have 100 J2EE apps that use EJBs and you want to move to Spring Beans instead for those EJBs, I think in many cases that is something you can plan in multiple steps. You implement another, concrete implementation of that EJB interface. You make it a bean. You inject it as a bean. You rip out the old thing. So you can imagine how you would, turn that into steps and execute it. That's, to me, that's what I always try to, like, I don't promise every kind of change. I promise the ones that you can think about systematically.
Awesome. Audience, continue sending your questions in the Q&A. We're going to do more Q&A at the end. John, one other interesting story that you told us, for you all, you use Develocity as well. And OpenRewrite is powered by Develocity. If anybody's interested in the OpenRewrite Develocity instance, we can show that. But John, you were talking about how you all, and you're going to have to correct me on this, as you all roll out Develocity, OpenRewrite or Moderne to different configurations and projects and whatnot, you want to check to see how well it's going. If it broke anything, you want to check I think I might have botched that a bit.
No.
Clay can say it better, but you want to talk about that a bit? And I don't know if you have this. Yeah.
We have this really difficult challenge that if we could share, screen being shared, like we've got code as text, right? That's what's in GitHub. That's what's in Bitbucket. It's code as text. But text is a very lossy representation, right? Like if I'm looking at this P method right here, the method call, what is P? Where is it defined? So if I want to change a particular method called P across my entire code base, I've got to be able to differentiate P's that come from the receiver type I care about versus P's that come from some other type I don't care about. And that's not visible in the text of the source code, right? When the compiler goes to compile that code, the compiler knows it has to solve for where P comes from. And that's called type attribution. So we turn this text into a syntax tree. A lot of security tools now are doing syntax tree searching. So they could find methods called P, but they couldn't tell whether that P came from list or whether it came from some other type. Like they don't really know. For OpenRewrite, we capture what's called the lossless semantic tree, which is the syntax plus everything the compiler knows and has solved for about all of those references, plus all the white space of the original code so we can preserve its formatting and style, plus a bunch of other information we stuff onto it at the end about like the class path and other things. And so this representation, super information dense, that's the thing that it's essential to us making significant change. But what it basically, and that's a long way of saying like, what that means then is we have to successfully execute the compiler on code, all of the code. Like, in the case of that open source tenant, we're talking 40,000 repositories. 40,000 repositories that use different Java versions, that use different Gradle versions, that use different Maven or Gradle, use both, use Bazel, use that, don't have any build tool, use Ant. The variations are just absolutely enormous, right? And so if I were going to try to embark on, frankly, this is kind of almost like, you have to think I'm a bit crazy for even trying this. Like, what if I could just build any arbitrary project by discovering all the like constraints that are required in selecting the appropriate thing? It almost feels like an impossible problem, but like that's the problem we signed up for. I'm going to parse 40,000 projects I don't control, and got to do that successfully. So we add as much logic as we can think of, but then overnight, say 20,000 of those projects fail. Why? Like, what is the next most important thing I could do to improve that success rate? And so, great thing from Gradle, they offered a Develocity instance to OpenRewrite, and we hooked up all of those parsing builds every night to Develocity. And early on, we were using Develocity's failure analysis to always identify the next most common source of failure when we were attempting to compile and parse a project into an LST. And so then like there's going to be a long tail of like individual problems, but we can just always prioritize the next most important thing, next most important thing, next most important thing. And I kind of think that tool is amazing for like productivity teams to like not get distracted by a problem they're interested in, but be able to prove like this is the most common failure in my organization. If I want to make an impact, this is probably the most important thing for me to actually try to, figure out and solve for.
And Clay, you can for the Zoom audience, if you want to share the Develocity instance of OpenRewrite. What's the URL again, John?
It's g.openrewrite.org. Yeah.
Easy.
Yeah.
Maybe Clay put that in the chat. And you all use you mentioned build scans as one of your favorite features in there, and how you all use that for so you're using that internally and externally?
Yeah, we're using that. Sure. We are compiling 40,000 open source projects we don't control every night. And, if I had my way, I'm going to make that 400,000 a year from now, right? Like, we're just like, our appetite is seriously large. And so things like Develocity's build cache, like that stuff, it's like the difference between it being very computationally expensive and something that's computationally feasible for us to do without like spending oodles and oodles of money on that. So made a big difference in helping us serve the open source community. And we like stories. Like one of my favorite stories from 2023 was our old friend Steve Hill from Netflix starting to write recipes, OpenRewrite recipes that would modernize Jenkins plugins. Because if you have an old version of a Jenkins version that's pinned to an old version of Jenkins and you deploy it to a new Jenkins master, Jenkins will do weird stuff like automatically add dependencies to the runtime to try to backfill all the stuff that's been ripped out, which could be super destructive to things on its left and right. And so if you just kept the plugins moving forward, it would actually take a lot of load off of these Jenkins masters. Well, there's like thousands of these, right? So you can understand why CloudBees is like, I'm not responsible for modernizing like 5,000 Jenkins plugins that like random people like built and then abandoned. But they kind of should be, because it's their ecosystem, right? So Steve started building these recipes, and he's working with CloudBees. They've made hundreds of commits to like plugins that are in their kind of space that have otherwise been abandoned to actually modernize them and move them forward. That's the kind of stuff I love seeing. Like, that's going to benefit all of us that use Jenkins, right? Because of the work of like one person in one of those companies.
That's awesome. And we're coming kind of to the end of our time together. Clay, any other interesting questions we could take?
Sure. We've got one more here in the channel asking about what it takes. Like, how easy is it to integrate a new language into OpenRewrite?
Yeah, it's a really good question. And languages are something that's like top of my mind, and one of the things that I try to focus on quite a bit now. We've discovered that there's these things called grammar islands of self-similar languages. Like, there's like the C family of languages approximately, and like Java, Groovy, Kotlin, C++, C#, Ruby, believe it or not, Ruby, Python, JavaScript, all kind of sit on that same island. At the LST level, this tree level that we were showing earlier, like they kind of look the same. In the syntax, like when you see them in text, they look very different. The way they're printed out, the text looks very different. And so, I just about finished the Ruby LST. You can see that out there in the open source org right now. That actually extends from the Java-based LST, believe it or not, surprisingly, maybe controversially. And so some of the common recipes I've written for Java just automatically work on Ruby code. So there's some like lift that we get from prior investments when the new language we're adding is on that is in that same island. But in general, like what it involves is building a parser from the internal compiler LST or AST to this OpenRewrite LST, and that's just work that we need to do. So C#'s on my mind. By June, you can see JavaScript and Python parsers out there in open source right now. Those need a little bit more TLC, I think. Ruby is also something very close to being done now.
What are your? I got one for you, John. What are your customers? What do they love the most? And I'm talking about the Moderne customers. What are they like? Hey,
I really think it's that, and I'm going to use this phrase again. It's like tech stack liquidity. It's you take an exercise that feels impossible, even if it's like Java 8 to 17. And if you can build a program for it, you can plan to actually get that work done, like without a substantial cost overrun, without like, like I get 30% of the way through this and then business priority shifts. And now like that really makes it hard, for organizations to move forward. And so I think it's to a business being able to move off of a technology onto another one, to be able to modernize your stack has like a lot of effects. I mean, it simplifies your overall architecture. It means you can negotiate with your vendors. You now are no longer like locked in and stuck. You can move, which means they don't come back to you with a huge price increase knowing that you're stuck, right? I mean, it's just a lot of like downstream effects, I think, of that ability to move. And I love that. One of the things I really love, and we work with some of the largest organizations as customers. I really feel like there should be a shift in responsibility for break and change from the end users of frameworks back to the framework authors. So when I worked on the Spring team and I made a break and change, that impacted every user of my framework downstream of me, right? I made the decision to break it, right? But that's going to affect everyone. So if I'm going to make a break and change, I should also be responsible for providing the recipe that fixes everyone downstream of me. And I want it to be like a competitive differentiator for a framework. If you're the Quarkus team who writes recipes, if you're the Micronaut team who writes recipes, like it means that if I use Micronaut, I'm not going to have to suffer through the next break and change. Like they're going to provide some automation for me. That's a reason I choose that framework over another one. And if you're a vendor that wants to like onboard customers more quickly, like we talked about with Develocity plugins, that's a way for you to like get in your, expand inside the customer base a lot more quickly. I think that's really important. And so when we work with large customers, if you think like big banks, an engineer at a big bank doesn't often feel cool, right? They like look up to the Google engineer or the Netflix engineer and say, oh, these guys are cool, but I'm over here at this kind of legacy organization. That legacy organization has a ton of power to say, hey, I have 10,000 apps written on top of Spring Boot, and I'm a customer of VMware's or Broadcom or whatever. Like they owe me, right? They owe me recipes that move me forward, or I can put spend at risk somewhere else in the portfolio. And so I want to see that responsibility shift back to, to benefit us all.
Well, you're surely doing it, John. I hear a lot of folks talking about your product, and you got that Amazon reinvent momentum there. And,
that's right.
Thanks everyone kind of for joining us. We have some stuff coming up for you next. Our next DPE lowdown is with the folks from Copilot. AI has been super hot, and Copilot folks are doing so. They're going to share some of their customer case studies and success stories on how their customers have improved developer productivity. I've heard a few as well that I'm going to throw in there. That one we have in March. You can sign up for it on Gradle.com or this QR code here. John, you have some good stuff as well coming up. You got your folks can get the OpenRewrite book.
Yeah, absolutely. Certainly just reach out to me and I'll send one to you. But I've got like 500 of them in my closet over here. But it's a little tiny O'Reilly book on automated code remediation, which I want folks to really understand that concept and be able to communicate it to their business.
And you all can get that from Moderne.io. And if you want more information, that's John's website. If you want to learn more about Moderne and the stuff that they do, you can go there. And we have some Gradle stuff as well. We got you can sign up for our developer productivity engineering newsletter. You could try out a free build scan to see what kind of data we capture. There it is, right there, the developer productivity engineering newsletter. We have a handbook on it as well. So we have some cool stuff for folks that want to get more into developer productivity engineering. And I think that's it. Let's let everybody get back to their next meeting in 7 minutes. John, thanks again for joining.
Thank you
Clay,
for having me.
thanks
Appreciate it.
for jumping on and helping and providing support. And John, we'll see you soon.
Yeah, see you soon.
Thank you, folks, and we'll see you all next time.